and then what number it is for the 2019. Okay, Enrico.
Number 12. It's both 2018 and 2019.
Number 12.
Oh, yeah, that was weird.
A solution of cobalt ions appears red when viewed under white light. Which of the following statements is true about the solution? And the answer is D, I'm assuming?
Yes.
Yeah.
Don't freak out about that one. They're going to be, for the Princeton review, there are going to be some questions that are going to, like probably one or two in each big idea that are going to seem completely out of the blue. Reasoning why. So if it appears red, okay, so the whole point, the color that you see is a result, the solution is absorbing every color except for red.
Yeah.
That's why you see a specific color, right? So the fact that this is pink, every color is being absorbed except for pink. Pink is being reflected.
What is electronic
transmission? Electronic transmission is what actually is able to pass through the solution. So the amount of reflected light will decrease. It does. Let me look at their explanation because I honestly don't agree with the answer of D. So let's look at this. A red solution appears red because it transmits red light, meaning that is not, that's the color that's not absorbed. Does not change as it, okay, it says the amount of light reflected does not change as it dilutes. The amount of light that is transmitted and absorbed does. So this is, in response to why is it not B, it says the amount of light reflected has nothing to do with how diluted it is, what is actually shot back. The amount that is transmitted or absorbed, that has to do with how concentrated it is, right? The more concentrated a solution is, the more it's going to absorb. The more light it's going to absorb. It has nothing to do with light reflection, okay? What this is saying, the reason why it's D, exactly as what I said, when you see a color, that is because that is the only color that is not being absorbed. So what I didn't know and what I just learned in this moment was not only will it be reflected back, but it's going to go just pass straight through it. So that red color, that is what will pass through it because it is not being absorbed by the solution itself. If it were blue, then blue would pass straight through it because every other color is being absorbed by the solution. That's why it looks blue. That's why the sky looks blue, because every color is being absorbed except for blue. Okay? Not a question I would ask you on a test, but interesting to talk about. Okay? Other issues you guys had with the multiple choice? Yeah?
Can we do number 13, which is the 2019 version?
So, number 13 for the 2019 version?
Yeah, and it's based on the following data, what's the rate law?
Oh, so A plus B produces C, same thing on the 2018 exam. Okay. Based on the experimental data, what is the rate law for the hypothetical reaction given above? So if you notice, from to determine the order for B, I would look at experiment 1 and 2, right? So from experiment 1 to experiment 2, B's concentration doubles and its rate doubles, which means it's first order, okay? Now I need to determine what the order of A is, but unfortunately B never stays the same, which makes this a slightly more tricky problem, but still very doable. So I know that B is going to be first order. So I'm going to write my rate law so I know that. Love it when Pee-wee kids leave my pens open. All right. So I'm trying to determine the order of A. I know that B is first order. And I'm trying to determine how that would affect my rate. Okay? So I'm going to choose 2 trials. I'm going to have A change, obviously. So I'm going to do 2 and 3. Does 2 and 3 work? Okay. So from 2 to 3, the concentration of A doubles. The concentration of B doubles. And my rate, remember, you're going to multiply all of these by 10 to the
third. Oh, these?
To get, right, it's 2 times 10 to the negative 6, 4 times 10 to, you're going to multiply by 10 to the 6th. That would make 2 times 10 to the negative 6, just 2, then 4, and then 1.6 would become 16. Okay? So from 4, no, we're on multiple choice 13. From 4 to 16, that is quadrupling. Okay. Shh. I'm glad you did. Okay, so what order is A? It's got to be first order. 2 times 2 is 4, so it's first order. So your rate would be... Guys, I'm going to go over any question people have questions about, because sometimes, even if you guys think you're rock stars at something, you make stupid mistakes.
No, that's not what I meant, because I asked what question we're on, and they're like 13, and I'm like, oh, I thought we were on short answer.
Got it.
To which I was obviously wrong.
Got it. Are we okay with 13?
Yes.
Yes.
Awesome. Sydney.
I was gonna say, can we do number
16, 1, 6?
yeah.
What year exam do you
2018.
The 2018. Okay, so after 44 minutes, it's that question. You guys have 16 as well?
Yeah.
Awesome, cool. After 44 minutes, a sample of K is found to have decayed 25% of the original amount present. What is the half-life? Okay, so if it's 25%, if I start with, let's say, 1 molar, after 1 half-life, I have half of the original amount, right? After another half-life, I'll have 25%, right? So 2 half-lives have occurred during this time, okay? So if 2 half-lives is 44 what? 44 seconds? Minutes? 44 minutes? How long is each half-life going to be? 22 minutes. So whenever you see a half-life problem, I would write it out like this, saying, okay, it's halved again. Okay? Any other questions from the multiple choice? Yeah, Mina.
Well, for like number 10 on 2019.
Is it a proposed mechanism?
No.
Okay, what is it? What can you read the question?
It says the above reaction will experience a rate increase by the addition of a catalyst such as platinum, which of the following best explains why.
Okay, give me 1 sec. I might just look at yours, because I don't know if you have that question.
Yeah, 2018, I don't think I did.
Okay, let me see your text from your book. And I'll read it for 2018. Number what? 10?
10.
Okay, the above reaction, so it gives us a reaction, will experience a rate increase by the addition of a catalyst, such as platinum. Which of the following explains why? So before I even look at any of my answers, what does a catalyst do to a reaction? It lowers your activation energy, right?
But I don't think there's any that have
Okay, so okay, so your options are A, the catalyst causes the value of G to become more negative. We haven't talked about G yet, so ignore it. The catalyst is B the correct answer?
I have no idea.
Oh, okay. The catalyst increase the percentage of collisions that occur at the proper orientation? Yes.
That is the right.
Yes.
Okay.
Oh, it said
So that a catalyst increases, hold on, no, let me look at all the answers. Increases the percentage of collisions that occur at the proper orientation. I would go with that. That would be one option. The catalyst introduces a new reaction mechanism for the reaction, or the catalyst increases the activation energy. So it does not increase the activation energy. That's the wrong answer.
I don't have you have the answers.
it's C.
The answer is C. Let's see why, because I disagree with that.
Let's go.
No, let's not go. Let's see why.
Thank you.
Because that's what the new mechanism does. Like B is what it does. It's like the same.
What question is
Nina.
Oh.
If it's the alternate mechanism.
I would be as well. Yeah.
I honestly would have put B.
Yeah.
I'm being honest.
Yeah.
So let's see why.
Let's go.
Catalysts work by creating a new reaction pathway with a lower activation energy. I agree with that fact, but the wording of this is weird. It introduces a new reaction mechanism.
Yeah, I had no idea what I was trying to say, so I was like,
I thought
okay.
we talked about that.
We did. We did. We talked about the fact that it creates a new potential
The new
pathway,
reaction, yeah.
but B, I'm wondering why, and they don't say why B is wrong, which bugs me. The catalyst increases the percentage of collisions that occur at the proper orientation. Catalysts help to make sure that they collide with the correct. I would have either chosen B or C, to be honest.
So,
And I probably would have gotten it wrong.
Wait, doesn't it not increase number of collisions?
The percentage of collisions that occur at the proper orientation.
I feel like it's the wording though, because it's like the percentage of collisions that occur.
Because a A catalyst helps to make sure that they have the correct orientation. That's why it speeds up a reaction.
Yeah.
It also can alter the pathway that a reaction takes to lower the activation energy. I agree with that. I don't, and I wish they had put why B was wrong. So I would just I'd put a mark next to B and C. Honestly, I would have probably put B, and I would have gotten it wrong. But then again, the last time I took a practice AP, I got like a 98% because I got 1 or 2 wrong. So I didn't get 100% on the AP. There's going to be a question or two that I disagree with. So just because I don't like the wording.
Mr. Zubi's always like, I never get a 5 on the AP exam.
I get a 5. I don't get 100%.
Feels bad.
Well, because there are going to be questions like that where you like doubt yourself and then you get it wrong. I honestly don't know why B is wrong, and I wish they'd put that, and I'll look into that.
Because wouldn't that speed the
Remember, because in order to have a reaction occur, you need enough energy and the correct orientation. Yeah. A catalyst helps with orientation, so I don't know why that is wrong. It must be something wonky about the wording.
Okay.
That they're trying to trick you, but I can't.
Is it the percentage part?
I don't know.
Okay.
I'll look into that one.
Got it.
Okay. Other questions 1 through 16. We feel okay about the multiple choice? No other questions about?
This big idea is like unusually easy, I think.
I told you guys you'd like it, and then you're like, oh no, we hate it. And then I was like, no, I think you should like it. And then you're like, oh, we like it. I was like, oh, okay, cool. All right. For response 1 through 6.
Yeah.
Well, because there's only a certain number of ways to ask these questions. Like, there's not that many ways to trick you, honestly. Yeah.
I was going to ask about short answer number 2C in experiment.
In experiment 2?
Yeah.
Do you have the 2018 or 2019?
I have the
2019, and it's the same in the 2018. Awesome. All right, so they give you this whole thing. They ask you to find the rate law in A. This is number 2. They ask you to calculate your K. Guys, please make sure. There's some of you, and I can remember reading your labs where you still got your the units for your K wrong. I don't want to take off points. Make sure that if you're having issues with units for K that you ask during this time. I'm about to answer C, but I'm just saying, please make sure to be able to do that, your units.
Oh, yeah,
okay?
So before you answer, like, help with C,
yes.
Is B...
yeah, for the units for K?
Yeah.
Okay, what did you guys get for your rate law for 2? Rate equals what?
NO2 squared.
So K times, it's NO... NO2...
Oh, no, it's just NO squared.
NO squared, okay?
BR2.
So BR2, so bromine is first order and NO is second order. Okay. All right. So remember when you're trying to, and if you look at your rate, the units for that are molar per second. Okay. Mm-hmm. Here's the first thing that's going to screw people up. I know I foresee you're frustrated. Okay. Really quickly, let's talk about the units and let's talk about why 2 is actually a really mean problem that I would have gotten wrong as well. Just letting you know, because we haven't talked about it. And I'll let you know about it, and you'll be aware of it, but it's kind of a pain in the butt. The units for your rate are molar per second. Okay? I don't know my units for K yet, so I'm going to just put K. Okay? Or I'm going to just leave a blank. Why not? Okay? Molar, this is molar, so molar squared times molar would give me molar to the third. I want just 1 molar, though, and I have molar cubed. So right now I need molar to the negative 2, because molar to the negative 2 times molar cubed will give me just molar, and then seconds will be to the negative 1. That will give me molar per second. Okay? For C, in experiment 2, what is the concentration of NO remaining when half of the original amount of BR2 was consumed? Okay, so in experiment 2, what was the concentration of NO remaining? So when you have half of BR2,
that's 0.5.
you need to use your rate law, correct? Do they have you use your rate law?
It's
I
Just
didn't
stoichiometry?
Yeah.
So it's like half
Okay.
times
So when you have, so that issue, I guess, doesn't, when did that, solving for your K is when that issue came. Can I really quickly go back to B to explain one thing really quickly? For B, if you notice your initial rate of appearance of NOBR, notice if you look at your reaction, there's a 2 in front of NOBR. Do you agree with that? Okay.
Oh.
To determine the rate that you should use in your rate law in order to calculate your K, you need to take whichever one of those rates you're going to use, and you need to divide it by 2. The reason why is because when we're talking about the rate, if you look back at all of the old problems that we've done, when you look at the rate, we're talking about the overall rate of the reaction. If we're talking about the overall rate of the reaction, we're assuming we're talking about 1 mole of each individual item, of each reactant or each product. Here, because you have a 2 in front of NOBR, you need to take NOBR and you need to divide it by 2, because that is double what the overall rate for the reaction is. Notice if you flip back to number 1, it gives you the rate of disappearance of A. So those are fine, because there's no number, there's no coefficient in front of A. If they gave you the rate of appearance of C or the rate of disappearance of B, you would have had to have divided by 2. None of the problems I've given you so far have given you a reactant or a product that has a coefficient in front, so you haven't had to do that yet. It's mean. I, honestly, would have gotten that wrong because I just use it. I don't even think to divide by 2. It's 1 point. But if you make a note to yourself and you notice on your test, or probably not on your test because I would have missed that, but maybe on your test or maybe on the AP, if you see that, divide by 2 and be like, they tried to trick me. If you don't catch it, it's a point. That's it. But if you can catch it now that I've pointed it out to you, that's awesome. All right, so that was for B. That's why a lot of people probably got B wrong, because you didn't divide by 2. I didn't divide by 2 either. Now I know that, now I'll look out for it. For C, in experiment 2, what is the concentration of NO remaining when half of Br2 was consumed? So experiment 2, if you use 0.01 of Br2, so half of it, I'm going to write my reaction because my brain is not working right now. Okay, so if half, guys, if I'm going to go over this, you're going to listen. Okay, half of the original Br2 was consumed. So you consumed 0.01 moles of Br2, right? Okay, I want to figure out how many moles of NO would be used to use up that many moles of Br2.
So it's a mole ratio.
Yeah, mole-to-mole ratio. So you're going to go 1 mole of Br2
Oh, it's two moles of
and 2 moles of NO, right? So that would be 0.02 moles of NO are used when 0.01 of Br2 is used. So since I start with 0.04 moles of NO, and I use 0.02, I'm left with 0.02 moles. Is that the answer?
Yes.
I hope so. I don't know any other way to do it. Okay. That was number 2. We've got 1 through 6.
Sorry, it's asking concentration, so that would just be
Oh,
moles
then
per
divide by. Oh, is this molar?
It's just
I wasn't even looking. Well, yeah. So this is molar. Sorry. This was molar.
Yeah, okay.
So you can still use the mole to mole. Yeah. Sorry about that. It's gonna be all in one solution so that you can still do the mole to mole. Okay. 1 through 6 questions.
Four through 6 were like really conceptual.
Did you understand for 4A how you determined that it was first order with just looking at that graph?
Is it the half?
The half-life.
The half-life is the same, right? The half-life will always be 40 seconds. Don't tell me it's curved, so it's first order. If it were second order, it would be curved too, and you guys saw that when you had other problems. I guess for your labs, it was always first order. But. Any other questions for 1, 2, 3, 4, 5, or 6?
6 really.
Okay. 6 was a great question. 6 was easy, but keep in mind, remember, if you look at B, I want to make sure people are okay with this. Remember, When you increase temperature, if we're talking this is your energy, yes, your energy increases. Remember, this is like a string and you pull it. What was this curve called?
Maxwell Boltzmann.
Haha, Maxwell-Boltzmann curve. Oh, I'm so proud of you guys. Oh, look at that. Someone had asked, I can't remember who it was. Actually, it was Mina. Yeah, good job. Mina, if this was velocity, remember, kinetic energy is 1/2 mv squared. Which of these curves would be for a smaller particle? A or B?
B.
B, because remember, the smaller your particle, the smaller the mass, the higher the velocity. Because remember, kinetic energy, the only thing that can change your average kinetic energy is what? Your temperature. Average kinetic energy will only change with temperature. Velocity will change with different masses. Another thing that I think came up a couple of times for your response, what is the only thing that can change your K? Temperature. So if you increase your temperature, what happens to rate?
Increases.
Why does your rate increase always with increased temperature?
There's higher energy collisions.
There are more collisions, they have more energy in the first place, right? So your rate's going to increase, therefore your K will increase, right? So that, I think, what number was that where they asked you over and over? Number 5,
Yeah.
right?
Like I gave the same answer.
The volume is decreased. Your rate increases, awesome, but your K will always stay the same unless you increase your temperature, which was for C. Okay? Are we okay with an inert gas not doing anything? Did that bug you guys? Are we okay? Inert gases don't do anything. They're inert. They're not going to affect anything. 1, 2, 3, 4, 5, or 6. You guys don't seem super stressed, which is good, but I just want to make sure if you have any questions that I'm answering. Rustin, you good?
Yep.
Okay, Diz, you good? Yep. Okay. You good? Be quiet. You okay?
Adrian's a god.
Are we all right?
Can we go over 3?
Number 3?
Yeah.
Decomposes according to the equation above. Oh, this was so mean. I love this question. Oh, this is wonderful. I mean, it's not that mean. Calculate the rate constant for the reaction using the values of concentration and time. All right. If it's asking for your rate constant and it gives you concentration and time and nothing else, can you use your rate law?
No.
No. That's mean. It tells us it's first order, though, right? So you need to use your lovely equation, which is on your cheat sheet and will be given to you on your test. Ln of AT. Are you trying to fight Adrian right now?
Why
Yeah, he's
is
trying to
being so mean
Just
today?
constantly.
Is it minus KT? Minus KT. No.
No, it's
Well,
minus.
plus-
I got it. It's been a long morning. Okay, so what is my initial concentration?
0.4.
0.4, okay? You can use any of these other concentrations, it doesn't matter. I'm going to just use the second one. So the concentration after 20 minutes is 0.289. Negative K. 20 is my minutes. Plus ln. My initial concentration is 0.4. And it's just math. Since this is first order, guys, what will my units for K be?
M
Time to the minus one.
minutes.
as to the negative 1.
Minutes.
Oh, it's
Number
minutes,
1,
M to the minutes negative.
no, not M times S to the negative 1. It will never be molar. It'll be molar to the negative 1, possibly molar to the negative 2. But because this is first order,
Is it just M?
S to the negative.
It's not
It's
M.
minutes.
It's
okay,
minutes.
minutes to the negative 1, right? Because this is just molar,
Do you not put
molar per minute,
wait.
right?
I think
Oh, okay.
And why do we assume? We assume it's molar per minute because, guys, we're measuring time in minutes.
What do you mean?
you just can't
Wait, we don't put molar?
For the unit for K?
Yeah, or
If it's first order, no, because it's first order here. You already have a molar,
or
right?
do they like cancel out or something?
No, molar, you're good. But I just want molar over minutes, so then I multiply by minutes to the negative 1.
So what's the units? It's just minutes.
Minutes to the negative 1.
Because it's
If it were second order, it would be molar to the negative 1 to get rid of the second and just have molar to the
Oh
first.
shoot! Okay, yeah. Got it
Minutes to
now.
the negative 1.
I thought it's just like M without any.
Do you want, Greg, you want me to keep going through the other ones? Or was that the issue you had, was A? How many minutes will it take to be 0.35? Again, you just plug it in, you now have your K.
Oh, so you would just change the.
You
T
change
then.
your LNAT to 0.35. This would be 0.35. You would have solved for your K already, right?
Yeah.
And then you don't know your time, so it'd be T. Okay. C, what will the concentration be? Again, now you're just solving for AT. You know your K, it tells you the time, and you know your initial concentration.
This one you're changing it to the N2.
Oh, for N2O. I think that was an error. That was a typo. It should be N205 still.
Oh, okay.
It says N203.
So that was the same as B, except
It's exact. All A, B, and C are basically the exact same. You're using this equation, but you're plugging in different variables.
Wait, so the initial rate of the reaction would just be for the 0.5.
Princeton.
Sorry, shh. I can't hear him. Calculate the initial rate of the reaction. Include your units with your answer. So the initial rate would be, so here you've got rate, we know it's first order, right? Rate equals K times your concentration of N2O5, right? If it says the initial rate, right, I'm going to use my initial concentration,
0.4.
and then my K,
Okay, you already
and
have
you'll
it.
get your rate.
And then,
Half-life
okay,
is super nice because it's
And it gives us
0.693
for-
divided by K. Or yeah.
you do it the normal.
Or you could plug in 0.4 here and 0.2 here,
and see what that.
and it'll still give you the same as 0.693 divided by K. All right. Other questions? 1, 2, 3, 4, 5, or 6? Yeah.
Is 6D the first graph?
6D?
Yeah.
The answer?
Yeah.
Yes, because notice you have A
Yeah.
as a reactant, B as a product, so you're going to decrease the concentration of A, increase the concentration of B.
Why don't the lines touch?
Why don't they touch? When you're in equilibrium, and we're about to get to that in this
But
next
it's
big
not.
idea, it will. Over time, so it says what it shows the changes in concentration over time. When you see them flatten, they are in equilibrium. So when you see it, so it goes like this. So your concentration of your reactant decreases and then it levels off. Your concentration of your product increases and then it levels off. Right here, and unless you screw stuff up, in which we apply Le Chatelier's principle, which we're going to go over again, you're going to be in equilibrium. Equilibrium means that the rate at which A becomes B equals the rate at which B becomes A. It has nothing to do with concentrations being equal. So like if I have 3 pens here and Mary has 1 pen and we just toss 1 pen back and forth between each other, that right? And then we do it again. I will always have my 3 pens. She will always have her 1 because she's losing 1 pen for every 1 pen I gain. That doesn't mean that we have the same number of pens, but we're still in equilibrium. Because if you had no idea what was going on, you would assume that we're not changing anything at all. Because I still have 3, she still has 1. That's equilibrium. Everything reaches equilibrium. Now, does equilibrium mean that you have equal amounts? No, you can actually have no reactant left over and only products. We'll talk about quantitatively how you can see whether or not what's going on.
So in this case, when the lines don't touch,
Yes.
this is equilibrium.
You're still, they could touch and they could be in equilibrium. The point is you see no change in concentration. That means equilibrium.
And so if they do touch, it's the same.
You're still in equilibrium, but they have the same concentration. Yes, that rarely happens. Okay. Other questions? We good? So you guys are going to work on 7 and 8. Okay. You right now have 55 minutes. Hopefully you will, I'm hoping, you finish. And then if you have any questions, we'll go over them as a class, 7 and 8. If you finish, I have your, and I'm going to pass this out to you. Remember, for the people who felt like they did really well on their last test, what they said was they went over, they redid the Princeton review problems, and then they redid the old worksheet problems and notes problems that I gave you. So I have this again, and I'm going to give that to you. Okay? On your lesson plan for today, I tell you your homework is to practice for your test. Do not study. What questions do you have? So 7 and 8.
So I got D right, but that's
I have no idea which one you're
oh
talking about.
sorry
8 D
Yeah.
as in dog.
yeah.
Okay.
I assumed that it was first order because of the lab.
It
but
says for crystal violet.
yeah.
Look at C. It says this reaction is known to be first order with respect to crystal violet.
Oh, so we have to. Oh, okay.
So it gives you that in C.
And then you
Okay.
can figure
Yeah.
out the other one. Figure out.
Yeah.
Yeah,
I
you
did
can
that.
figure the other one out based on the data. Michael.
So, for the units for absorbance, it's just A.
For units for you don't need any units for absorbance. Nope. No A, no nothing, just the number. That's perfectly fine. Guys, I thought it was Gerald had asked me this one for 8AII. If the solution placed in the spectrophotometer 30 seconds after mixing instead of immediately after mixing, how would that affect the calculated rate of disappearance? Keep in mind, guys, as a reaction proceeds, your rate gets slower and slower and slower. So if you place it in the spectrophotometer 30 seconds after the reaction has occurred, all of the rates that you calculate from then on are going to be slower than what they should be because the reaction itself is slowing down. You missed out on that 30-second gap in which the rate was at its highest, right? And so it's gonna be quite a bit slower. I think that's a great question. Makes you think. Any other questions for 7 or 8? Okay, so remember, best way to review, redo the multiple choice from this Princeton review. Okay. What I can do, I will post on Schoology. I will take pictures of all of the multiple choice and all the free response. I'm going to post it on Schoology. I'm not going to print it out. Okay, so redo those problems. Redo the problems that I gave you in that packet. And then the other thing that I told you to do on your lesson plan was also to redo your quizzes, to rework your quizzes. Just for you guys to know, Monday is your test, obviously. But Monday is also the last day for you to turn in anything that is missing. So if you have stuff that is missing that needs to be turned into me, that I've NA'd because I was nice, it's no longer going to be NA'd. I'm putting it back as missing. Okay, please turn it in or else it will be a 0 on Aries. Okay? We good? Awesome.